Now we will discuss in detail about the different test techniques that we are going to use. So first of all, the black box technique will be discussed in detail with all of its types that are being used widely. So first of all, the equivalence partitioning, also known as, in the short form we call it as EP. So okay, so equivalence, what is equivalence partitioning? Actually, equivalence partitioning, and first of all, I will tell you that it can be applied on all levels, test levels that we have seen already. Either component level, you have ideally this type of black box testing can be applied on all test levels. So the main question here will be uh, like, what is the equivalence partitioning and how it works? Actually, this equivalence partitioning, uh, um, like normally it is widely used in that particular test scenarios where we have the ranges, and for one particular range we have to take only one value. We will definitely see more in detail about the numericals or mathematical question of this type, but right now we will discuss the theory. Equivalence partitioning divide data into partitions, also known as equivalence classes, in such a way that all the members of a given partition are expected to be processed in the same way. There are equivalence partitions for both valid and invalid values. First of all, I will give you a practical example, and then we will go through the theory. Let's say we have three categories. They say that we have 1 to 10, 20 to 30, and 40 to 50. We have these three ranges. Let's take an example, maybe of any case. Let's take that there are some passing grade. For example, for 1 to 10 there is X. For 20, not passing grade, we can take any, like any particular speed. X type, if it is 20 to 30, it's Y type. It's 40 to 50, it's Z type. And they ask in the question, find the test cases required, minimum test cases required from the equivalence partitioning. So what you will do, first of all, you see there are three classes are given. The first class is 1 to 10, the second class is 20 to 30, the third class is 40 to 50. Sorry, so there are three classes. Actually, if you say the class X, either you take value 1 or 10, all will have the same behavior. They have divided it in such a way. If it is of class Y, all the values will have the same behavior. If you have a class Z, 40 to 50, all the values will have the same behavior. So if you have to do the testing, you can take any value, any single value from 1 to 10, like 1, 2, 3, 4, 5, any single value. This value will tell the complete behavior of this particular class. You don't need to test that particular module or your object on all the values of this class 1 to 10. No, only one. Similarly, for class Y, you can take any value from 20 to 30. Any value. It will actually represent the whole class of Y. So two values. Then 40 to 50. Again, the same behavior. Any value if you take from between 40 to 50, it will behave in a similar way. You don't need to check it. For example, if you have a normal case, then maybe you need to if you are testing the all values, you need to take 10 values from here, 10 values from here, 10 values from here, to 30 in total. But like right now, for example, in the case of equivalence partitioning, you can take any one value from here, any one value from here, any one value from here. So it will help you a lot in that case, that your test cases are very minimized. So minimum test cases required in this case is 3. These all were the valid classes. Let's say if the value is less than 1, for example minus infinity to 0, that's the first invalid class. And for example, if it is not allowed greater than 50, then 50 to infinity positive value, it's again an invalid class. So then if they ask you in the exam, find the minimum test cases for all valid values. So you know 1 to 10, 20 to 30, 40 to 50, you have 3 test cases for the valid values. If they ask you to test for all the valid and invalid values, then these 3 test cases plus 1 from this invalid class, minus infinity to 0, and 1 from this invalid class, plus 52 plus infinity. So 5 test cases, valid plus invalid. There is one trick for you. If in exam they ask you to find equivalence partitioning, they ask you to find the minimum test cases for the equivalent partitioning. If it is not mentioned, then you have to do it for both valid and invalid, but sometimes they ask to do it for valid only. So now we will go through the theory. Now you will understand in detail. Valid values are values that should be accepted by component or system, and equivalence partitioning containing valid value is called a valid equivalence partition. So in this case, 1 to 10, 20 to 30, 40 to 50 are all our valid equivalence partition. Invalid values are the values that should be rejected by the component or system, and equivalence partitioning containing invalid values is called invalid equivalence partition. So it is our invalid equivalence partition, minus infinity to 0 and 52 plus all the values. Partitions can be identified for any data element related to test object, including input, output, internal values, time related values, e.g. before or after an event, and for interface parameter, integrated component testing. Like partitions, you can do partitions for any kind of testing, for any kind of data, input, output, internal values, time related values. Just you have to do the partitioning of that data. You have to make classes of that data. That, for example, if I will give you an example, I have 1 to 100 values and they say there are 10 different classes. So I will make 10 valid classes, 1 to 10, 11 to 20, 21 to 30, so on to 100. So 10 my valid classes, and invalid will be 100 and greater than that, and 0 and less than that. So it is a kind of same behavior, same data of same behavior is put in the same class. As I told you here, the values from 1 to 10 behave in a similar way, so they were put in the class X. Value of 20 to 30 behave in the same way, so they were put in class Y. Values from 40 to 50 behave in the same way, so they were put in the class Z. Any partition may be divided into sub partition if required. Even you can do sub partitions, like 1 to 10 is a partition, you can do sub partitions if you need to do that. Each value must belong to one and only one equivalence partition. So if, for example, there is a value 2, it only belongs to the partition X or equivalence class of X, 1 to 10 class, but not to the any other partition. When invalid equivalence partition are used in test cases, they should be tested individually, i.e. not combined with other invalid equivalence partition, to ensure that failures are not masked. So if you want to test for the invalid values as well, so you have to test them individually. Failures can be masked when several failures occur at the same time, but only one is visible, causing the other failure to be undetected. So there is a concept of mask failure. For example, if you test the invalid values all together, like 50, for example, in this case we said values greater than 50 are invalid. So maybe you use you have tested the invalid values 51 to 60, all 10 together. Maybe on 51 this is an invalid value, but in that case you will trigger some other fault. Maybe in case of 52 there could be an other fault triggered. But for example, if you test all the invalid values together, you will come to know only about one fault or one error. Maybe the other errors are behind that errors. Like normally whenever you are working on if you are a developer, you are developing something, sometime through compiler you come to know that, or your IDE, you come to know about an error, and if you remove that error, the next error will come. That means the first error actually was masking the previous error. So if you remove it one by one, then you will unmask the error. So whenever you are testing invalid values, test them individually. It is very important tip. To achieve 100% coverage with test technique, test cases must cover all identified partitions including invalid. For example, in this case, if I see 3 valid and 2 invalid, so if I take 5 test cases, that means 5 out of 5, 100% test coverage. If they ask me to do for both valid and invalid values, for example, and then I take only valid part, means these three partitions, not the invalid one. So 3 out of 5 will be somewhere around 75% or 66 point something percent. So then it will not be 100% coverage. So by using a minimum of one value from each partition. Coverage is measured as the number of equivalence partition tested by at least one value divided by total numbers of identified equivalence partition. So normally it is in percentage. It is not about the valid test coverage or invalid, it's about the overall test coverage. If you have 5 partitions, 3 valid, 2 invalid, just take one test case from all of 5 classes and it will be 100% test coverage. Equivalence partitioning is applicable at all test levels. Very important line. It is applicable at all test level. Component integration, either component integration testing or system integration, system testing, acceptance testing, all on all the test levels we can apply this equivalence partitioning.